Good morning, students. Welcome to Gabby's Tutorials. Today we are looking at Laplace transform. So the question here says, show that the Laplace transform of cos kt is equals to s over s squared plus k squared. So first of all, we start off by writing the definition of Laplace transform, which is Laplace f of t is equals to integral of 0 to infinity f of t times e minus st dt, where f of t is equals to cos kt. So when you plug in cos kt in the equation, you have Laplace cos kt is equals to integral from 0 to infinity cos kt times e minus st dt. So looking at this equation, this is an integration of product or integration by part, and the formula is given below here. We have the integral u dv is equals to uv minus integral v du. And in solving integration by parts, there are conditions to consider before choosing the function of u. And one of the conditions is that when you have trig function and exponential function, the trigonometric function is u. So in this case, u is equals to cos kt and dv is equals to e minus st. So when you differentiate cos kt, you have that du is equals to minus k sin kt dt. When you integrate dv, you have v is equals to minus 1 over s e minus st. I hope you know how to integrate exponential function. It's simply dividing the exponent by the differential of the index. So when you differentiate st, you have s. So when you divide, then you divide it by s, which is minus 1 over s e minus st. So now we have all the parameters needed for the integration by parts. So we plug in the values in the equation above, so that you have that uv is equal to cos kt times minus 1 over s e minus st, which is given as minus st cos kt e minus st from 0 to infinity minus, then for this integral v du here, you have du, which is this multiplied by this. You have minus k sin kt dt times minus 1 over s e minus st, so that you have the value here. This k over s is from these two constants, because minus k times minus 1 over k all over s will give you k all over s. So you bring it out of the integrals, so you have this value. So that means we are still going to integrate again, but before then we calculate for the upper and lower limit of cos kt e minus st. So when you plug in infinite in this equation, you have 0. That's why you have 0 here. So when you plug in 0, you have that cos 0 is equals to 1 and exponential 0 is 1. So you have 1 here. So minus 1 over s times minus 1 will give you positive. So you have it down here, but before then you have this minus this value. So you will repeat the integral by part again. So u is equals to sin kt, and the dv is equals to e minus st. Then differentiate sin kt, you have k cos kt dt. Then integrate dv, you have that v is equals to minus 1 over s e minus st. So you plug in the value in the integration by part formula again. You have that uv is equals to sin kt times 1 minus 1 over s e minus st from 0 to infinity. So you have this value. Then you have the but before then, you know that this integral is k over s is constant. So this is this k over k s open bracket for the second integration by part, which is uv. So you have this times this. You have this minus integral v du up there. So you have v du is k cos kt dt times minus 1 over s e minus st. So you have this value here. So when you simplify it, you have that 1 over s minus k over s open bracket. You have, when you plug in the upper and lower limit of the integral, so you have sine infinity is 0 and sine 0 is also 0, so you have 0, 0. The first part is out, plus the constant here is k and minus 1 over s, so you have minus k over s. When you bring it outside the integral, you have minus minus is plus, you have k over s. Integral from 0 to infinity cos kt e minus st dt. So this is the same as the equation we started with, so we can replace it by Laplace cos kt. So you have that Laplace cos kt is equals to 1 over s minus k. So this is k over s times, this is 0, so it's out. So you have k over s times k over s minus k over s times k over s will give you minus k square all over s square. Integral from 0 to infinity cos kt e minus st dt. So you replace this by Laplace cos kt, so that you have 1 over s minus k squared over s squared Laplace cos kt. So, same as this. So now come to the final stage. You have that cos kt. When this crosses the left hand side is plus, so you have this, which is Laplace cos kt plus k squared over s squared Laplace kt cos kt is equal to 1 over s. So when you simplify it, you have Laplace cos kt open bracket 1 plus k squared over s squared close bracket is equal to 1 over s. So when you have that, when you make Laplace cos kt substitute the formula, you have 1 over s multiplied by s squared over s squared plus k squared. So s cancel s, you have 1s all over s squared plus k squared. Thank you.